Hi, I'm Mickey and this is my Dyoe. My testable question is, does the length of the pendulum affect the time it takes to swing? Hypothesis, if I use a shorter string, then it will swing the fastest because it will travel the least distance. These are my variables. Materials list. Here are my procedures. This is my trials for 10 centimeters. My trials for 20 centimeters. My trials for 30 centimeters. Trials for 40 centimeters. Trials for 50 centimeters. And my trials for 60 centimeters. Photos and videos I took. My observations during the experiment. This is the average time for each of the lengths. Percent changes, I'm not sure which one to do, so I just did all of them. My conclusion is, does the length of the pendulum affect the time it takes to swing? If I use a shorter string, then it will swing the fastest because it will travel the least distance. My hypothesis was rejected because the average time of 10 to 60 centimeters was 1.9 seconds and only a 0.65% change. My hypothesis would have been supported if I used longer strands of string. My time averages 0.63, 0.98, 1.29, 1.34, 1.38, and 1.82 wasn't even a big difference. Possible errors that I might have made is the length of string might not be the same every time because I did it in Mr. JP's room and at home. Another possible error is that it might have not been swinging 30 degrees each time. A real-world application of this could be a wrecking ball and how fast you would like to demolish a building. A principle of science is Newton's first law, or the law of inertia. An object at rest will stay at rest unless acted upon by an outside force. An object in motion will stay in motion unless acted upon by an outside force. Here, the outside force that stopped the pendulum from continuously swinging was my hand. But if I left it swinging, it won't swing forever because the rope provides friction and air friction. A new question I have is how different materials affect how long the pendulum it takes to swing.